Welcome to Cheesemake by Roman Dmitri, where I use 3D printing to solve niche problems for which products on Amazon do not exist. If you're curious about the hair, it's because this script took me 6 hours to write, so you'll just have to deal with it. You'll soon find out I really don't care what I look like. Today I'll walk you through my entire design and print workflow. This video is for you if you're thinking about getting into 3D printing and are just curious about the overall process. Or if you are 3D printing and are curious about my process specifically. The steps are generally as follows. Make a project folder. Start drawing the materials. Take your measurements. Do design and modeling. Slice it up. Print. Iterate. 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 Post-process. Success. Now let's get into the details. And I want to emphasize that even a simple project will take anywhere from 2 days to a few weeks to complete. Project folder. Once I have a project in mind, I create a folder for it on my computer. This makes it official. I have now consciously decided to do this. I keep my folders in chronological order by adding a date prefix that looks like this. And I keep my project titles as short as possible. Here's what my 2025 project folder looks like. And the new folder for today's example. Next is drying. This is crucial for many materials. Most materials absorb moisture while they sit on the shelf. And during printing, the heat of the nozzle evaporates that moisture, which can lead to poor print quality. PLA is pretty stable, so I don't bother drying it, but my other materials require at least a few hours at 65 degrees Celsius or above. I got myself a Print Dry Filament Dryer Pro 2 a few years ago, and I have no complaints. I see the Pro 3 is now available and goes up to 85 degrees Celsius. So I might benefit from the upgrade. I also use their storage containers, and at $80 Canadian for a 6-pack, it's a fair deal. They look like this, and I have 12 so far. Measurements? My practical problems tend to involve specific measurements, so I rely on a digital caliper. I bought the cheapest that I could find for about $35 Canadian 4 years ago, and it came with a really sweet box. I always first buy the absolute cheapest product that I could find so I can learn what I hate about it before upgrading to a more expensive alternative. But this cheap caliper has served me well and I see no reason to upgrade to a $200 option. Pro tip. Always store your caliper with the battery removed. It's annoying, but less annoying than having to find a new battery just because you forgot to turn it off the last time you used it. Also, this one tends to drain the battery even in the off state. 3D modeling. 3D modeling. 3D modeling. This is an essential part of the workflow. I use Blender for my designs. Let's get into my configurations, use of modifiers, and how I export. Blender is free and is incredibly powerful. You can make entire movies with it. For 3D printing, you'll probably only use 2% of its functionality. I found it relatively easy to learn because it has excellent tutorials all over the internet. I grew up watching Andrew Price over at Blender Guru, so that would be a great place to start. File name. I name my files one leg at a time. My file names consist of 3 parts: the date, the project, and the revision. Each significant change to the design warrants a new file. As soon as I open Blender, I save my file right away. This way I can press Ctrl+S obsessively for absolutely no reason. With Blender, when you go to Save As, you can press the plus button on your numpad to increase the revision number. Just make sure you hover the file name when you do that. It should be highlighted by default. I typically have 10 revisions per project, with as few as 2 and as high as 60 as discussed in my previous video. Configuracja. Once I've created my file, I delete everything in the scene and remove the gizmo. That shit's just right annoying. I then change the units to something appropriate, specifically set the length to millimeters, because we're printing on a small surface. For my wood project, I use inches, but that's a little off topic. Design. I always start with the draft design and iterate it until it becomes the final product. The goal of the draft is to size the dimensions as close as possible. We're not thinking about aesthetics just yet. I then refine the design while printing a draft. I design with gravity in mind so I can avoid support structures. Modifiers. There's a set of modifiers that I typically use and I want to showcase them to you. I won't go into details, I just want you to know that they exist. Here's the shape we will use for the demonstration. Mirror. I'm a robot, so I like to keep it symmetrical. The mirror modifier lets me do that. Solidify. Use this one to give the model thickness. 3 millimeters works best for me. Subdivision, surface. Subdivision. Use this to smooth out the model. I use anywhere from 3 to 5 levels in the viewport, and these are the ones that get exported. The render levels are ignored. Edge crease. Use edge crease to selectively sharpen edges. That's pretty cool. And helpful. That's very helpful. Thanks for the tip. Boolean. 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 The Boolean modifier. This one is great for subtracting objects. I use it for making screw holes. How freaking awesome is that? Export. First, select the relevant objects. Then choose STL from the export menu. In the export pop-up, be sure to click Selection Only, and set scale to 1000 to compensate for the millimeters. Otherwise, your model will be tiny, kinda like your... That's what she said. And of course, click Export. Slicing. 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 The slicer software converts your 3D model, like that STL file we just exported, into a G-code file that your printer can execute. G-code. 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 I have a Snapmaker, so I use their software called Snapmaker Luban. I don't know how to say it. Luban. Luban? On Linux, I started like this. And if you're curious about the terminal, you can check out my other YouTube channel called Cheese Code by Roman Dmitri. Once it starts, it looks something like this. I select 3D printing, and I'm ready to go. For drafts, I always use PLA. And I crank my settings in whichever direction will minimize print time. Just drag and drop your model to get started. That looks pretty sweet. Pressing generate will give you two important pieces of information. Number 1, print time, 9 hours. And number 2, the materials required, 135 grams. If a kilogram costs you $20, this will be about 3. My drafts are about $1, and the finals are anywhere from 10 to 15, depending on materials and infill density. For a fine print, I set my height to 0.12 millimeters and infill density to 100%, because at this point, time is no longer a factor. My goal is to always get the best result possible, within reason. The Snapmaker can go thinner, like 0.08 millimeters or less, but at some point I guess I forgot and 0.12 has been perfectly fine. At 0.12 millimeters, this print will take 40 hours to complete and about the same weight in materials. That might seem like a long time, but if you only need one of these and it will last you a while, then what difference does it make? Next, let's talk about export. 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 In theory, the Snapmaker supports Wi-Fi printing, but last time I tried it, it didn't work. Instead, I saved the G-code to this, multipass. The folder structure looks something like this. I have a folder for prints and a subfolder for each project. And within each project folder, the G-code files are named with revision and material. I keep the names short so they're easy to read on the Snapmaker interface. Printing. How do you print? Yes, printing. What is printing? Что-то printing. Что такое printing? Now you take that USB drive and shove it up your printer and start printing. For draft printing with PLA, I have no real tips. It always works just as expected. For final prints, I use high heat materials which require a hot bed. That's steamy. It actually makes this room quite hot. That's steamy. For carbon fiber, 80 degrees is recommended, but that print bed takes way too long to heat up. That's completely unacceptable. Instead, I set the bed to 60 degrees and use glue stick to compensate for the lower temperature. Washable glue stick. Elmer's washable glue stick. I use Elmer's washable glue stick in Disappearing Purple. It's great. I bought this 3 years ago and it still does the trick. If I absolutely need a 90-degree bed, I'll put the printer in control mode and set the temperature manually. Then I let it heat up while I tweak the designs. By the time I'm done, it's usually ready to go. I just want to note that the glue has started to destroy my print sheet, so soon I'll be getting a new one. I wanted a print sheet on the bed. I wanted a sheet on the bed. Once the print is complete, I let it cool down to at least 50 C or below, and then I scrape the print off. This helps prevent warping, which is the last thing you want after a 2-day print. A lesson I keep having to learn. Post-processing. What's that line from Grandma's Boy? I'm a robot. Post-processing. I don't do any of this. For me, I simply remove the glue and use 80 to 400 grit sandpaper, and I call it a day. In my future videos, I'll show you my projects, and you'll see it's not really necessary. Well, thank you. I hope you found this informative, and at least entertaining. I hope you found this informative. Please like and subscribe, and leave your questions, comments, concerns down below. Thanks for watching. May the Lord open, and praise be. I use Elmer's glue stick. They don't pay me for this.